I just kickstarted the recording, and I think we could get started now.
Okay, okay. Welcome everybody to another session today. Okay, so today we'll be um writing a basic messaging app. Okay, that functions like Twitter, but it's not gonna have all the full kind of functionalities that the Twitter we know, of course, have. Now the whole idea is to get us used to what smart contract is all about, and we are going to be using Hardhat. I've also scaffolded a sample already with me, so we don't have to waste time trying to install it right here. Without wasting much of our time, now if you have any question as we go, please do not hesitate to call my attention back and ask a question. Please don't let it like go too far and then all of a sudden you say I don't understand anything at all. I mean that's not going to help us at all. And the whole point of being here is to be kind of productive in the end. Okay. All right. Thank you. So I will share my screen right now. Um, I want to share this code. Okay, let me just share the entire stuff. Share. Okay. Please, I need someone to confirm if you can see my screen right about now.
Yes, we are seeing your screen.
Yes, 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 sir, yes, sir.
Okay. Thank you. Thank you. Um, so the first thing to do is to go into the contract folder and I'll call it Ita, Ita.so. Okay. And like we all know, we start off by writing the um, license as SPEX slash license. The normal, usually copy and paste this. Let's just identify by using MIT. Okay. Next thing, the compiler version we want to target, that's Pragma. Validity the version, I'll go for 0.8. Um, okay, so we have contract, right? The name is Twitter. Now let's try and maybe try and understand how Twitter works. Like if you want to do some kind of interactions on Twitter, first thing I think you have to do is first of all you create an account, right? So if Mr. E goes on to create an account, the account should have at least the person's name, his email, say handle, right? And then there could be other information, maybe location and stuff like that. Of course, talk about followers, people they are following, and messages they're sending. So all this information will be captured under one person. As such, in order to make our code, kind of organized, we could capture every user details in a struct, right? So we say struct user. Um, Now for our own case, we don't really need emails. Rather, we need an address. This is a decentralized app, right? Okay, call it wallets. Um, one thing we might need is the name, which should be a string. Third thing, maybe list of, after you've registered, eventually you begin to interact, you begin to post, begin to tweet. So we need to get a list of the person's tweets, and we store the IDs of these tweets. Okay, the ID. So we have an array. Sorry, array, call it user tweets. Ooh, so many E's. Okay, I know it in presence. So after this, the next thing we might want to do is, after the person have registered, now the person can actually tweet, right? And for each tweet the person is making, there has to be a content. That's like a string the person will add. There has to be time, like timestamp, right? The tweet was
Yeah,
sent.
sorry for interrupting, Tissy.
Okay,
I don't know. Like, it's the font size. Can you increase it a bit? I don't know if it's comfortable with everyone,
okay,
but I think I would appreciate if you increase it a bit on mine.
all right. What about
Yeah,
this?
this is better now. This is better. Thanks.
Okay. You have installed Docker later. Okay, um, so like we're saying, the tweets now, of course, we have some attributes as well. So since it will have specific attributes, let's capture everything as well under a struct. So we go for struct, call it tweet, right? And then we go for the number. We need to kind of keep track of the tweet as they go. Number one tweet, the second one, third, and so on and so forth. So we go for UN's um, tweets ID, tweets ID. Okay. And then we need the author. That should be a string, right? Okay, let's use address for this. Address, author. Okay. And then the content. Yeah, content. And then the time the tweet was sent. So this is like a figure as well. It should be UN's created at after this. I think we've captured one or two stores. Next thing now we have to do, for each person that wants to register an account on Twitter, they will come with their address, their wallet address, and they will have all these to them, right? So it means if I want to register, I'll come with my address and I will have all these properties under me. Now, if Mr. B comes to register as well, Mr. B will come with his or her wallet, right? And he will have all these details that I highlighted. So in order to keep track of these developments, we use mapping, right? Mapping that maps address as they come, right? Oh, sorry. Okay. And we're mapping it towards struct user. And we could capture the name, make it public, so our setup function is set for us, one of the users, and then we go with this. Now also, there's a need for us to track the tweets as they come in. The tweet one, tweet two, and so on and so forth. So we use mapping as well to keep track of that. Mapping UINT now. going towards this guy here, right? So this other guy tweets as instruct tweets, and we call it should be public as well, and then tweets. So after this, um, I think with this we are ready to create our first register our first account, right? Because now we can track the users as they come and go, and also we can track the tweet they will make. So to begin with, um, we also need a way to track these IDs and make it readily available in case someone else wants to maybe tweet, right? Because this tweet belongs to this guy. So if we can have another state variable, uint, okay, uint 256, and all of them works. Public, and call it next tweet ID. Okay. So the next thing we have to do right now is to create our function, right? The function that creates accounts. You have to register before you can interact. We already established that fact. So go with function, call it register, um, register account, right? And then it's gonna take the name of the person calling this function. Obviously, the person calling the function will come in with a certain address, which I think we all know it should be the msg.sender, right? If you're the one calling the function, there's an address you're using to interact. So um, we go with a string here. I will make it a memory operation, right? Underscore name. That's the name of the owner of the account. And then we want to set it to external just so it can interact with other contracts, no big deal. And then now the name coming in is actually um, a string, right? But we need to make sure we have to do some kind of sanity check to make sure the person calling this function is not registering like an empty field, doesn't leave this field empty, right? So in that case, the person won't even have a name. You need to make sure that person enters at least one alphabet, one character. In order to do that, we can't really get the length of string in Solidity at the moment. I don't think there is a way to get it. Unlike maybe saying Python now, if you want to get the length of a string, I think there's a function for that called length, just passing the variable that contains your string, and the function will output the length of the string. But here in Solidity, we don't have something like that. So we use bytes. Okay. We typecast the string and convert it to bytes. So we do something like this: bytes, um, memory, it's going to be memory operation. Let's call it b name is equal to bytes, right? And then the string we are passing in as name. Okay. So after this, we can now do our sanity check and say require condition is this, that bname bname dot length, sorry, dot length, that's the spelling of length, yeah, it's not equal to zero. It shouldn't be equal to zero, please. Yeah. In any case, if the person doesn't want to put something reasonable, we give him something, say name cannot be an empty. Um, okay, type well, empty string. So there has to be something there. Um, so this once this guy fails, everything stops here. But if he passes, then we have to set this a certain address against the name. Now we to do that, we access our storage, say user, because this is about the user, right? User accessing storage, and we get our storage pointer, call it a new user, okay, is equal to we target our mapping here. That's users, and then it's the person calling the function obviously. So it has to be msg dot sender, and that's it. So right now, this is our struct actually, and we've captured it right here, and then assign the value to it. So now we can use a sort of the structure, or it's not it's not the structure actually, but the thing is now is we'll have access to everything that is contained within this struct here, right? User struct. So once we get the address, we can now say that new user, right? Um, dot wallet. Now we are accessing these guys here. These guys dot wallet um is equal to msg dot sender, the person calling the function, right? Msg dot sender, and then we also set his name or her name, as the case might be. Dot name is equal to um well the name the person is going to pass here obviously, so underscore na name, right? Okay, so with this we've created an account, and we can actually test this out using remix, okay, to see if it works. But let's keep that on hold for now and try implementing something else. So another thing we might want to think about now is this. Like we said earlier, if you want to interact on Twitter, you need to have an account. So if you want to post, make a tweet, you need to have an account obviously for that. If you want to follow someone, you need to have an account to do that. If you want to send someone a message, you need to have an account to do that. Like interactions on Twitter, right? Maybe viewing posts, you can actually not log in and you can still view posts, but there are so many other things you can do. Without your account, you can't do those things. So not to repeat, having accounts, making sure that the person calling the function has account or something like that, we are going to implement a modifier, right? That checks, the modifier checks if, checks to know if an account is registered or not. Okay. So with that said, start by writing our modifier, the keyword modifier, right? We call it account, um, account exist, right? And then it's gonna take in address. So we pass in a certain user. We're trying to find out if this user actually is registered. So next thing we have to do is we assess um our user struct, right? So we initiate our user struct. So far I don't know if anybody has question as to what we're doing. You can ask so that I'll clear your doubts. Of course, I'll do my best to clear your doubts. Any questions so far? I hope I'm still talking to some people, or am I speaking to myself?
You can hear you,
Yeah,
sir.
yeah, still talking to us.
Okay,
No
everything is
question.
okay. Okay, everything's okay so far, right?
Yes, sir.
Uh,
Okay, wait, I have a question, right?
all right,
Hello.
please.
Okay, so what's the point of storing the user? Okay, like a user creates, well, okay, the mapping, right? The
Yeah.
key to the user is the user's address, right?
Yes.
So why do we still need to store the address of the user inside the user?
Which line exactly are you talking about?
That's in the user struct.
User struct.
Sir,
Are you
please
talking
scroll
about
up.
the entire
You get?
this place?
Yes. So we are mapping the user's address to a user, but we
Yeah.
still store the user's address inside the user. Like, is it very necessary?
Yes, it is. Because your address is different from my address, right? The address
I don't
here
know.
is
Uh-huh.
the address here could be mine,
Uh-huh.
right?
Yeah.
And another one could be yours. So everybody has to have their own unique addresses. Every person coming to Twitter. Just like when you interact with OpenSea, when you want to view your NFT, you have to go in with your own address, right?
Yeah.
And not mine. So
Yeah, I get. Hold on. Like, I'm talking about in the map. Okay, like the user bar, we store the address inside the user. Then when you now
mm,
come to the mapping, the key to the mapping is also the same user's address, right?
it's not the same. They're not the same.
It's not the same. They
That's
are not the
that's
same.
why we had to set it here. Can you see this line 32?
Uh-huh.
We had to set it so that we'll be specific about the particular address we are referring to.
Okay.
Yes,
Okay.
yes.
Okay,
Thank you.
thank you.
Yeah. So continuing. So to check if an account already exists, we bring down our struct, which is actually a storage variable, right? Um,
Excuse me, sir.
storage. Okay.
Please, can you just scroll up once more, please?
All right.
Let me take a screenshot. Okay, thank you.
Screenshots. I don't think you need that for now. Unless if you can follow along as I'm typing, that might be the best because going back and forth like that might not help our timing. Okay.
Yeah, yeah,
Besides,
yeah.
you have all this code when we are done.
It's very all right, sir.
Yeah, you have everything. Thank you. So, like, we access the storage and then we give it a pointer. Say this user, okay, is equal to what? Um, we refer to our mapping and passing this guy underscore user. That's this guy here is the person we are trying to check for now. Uh, I made the process, and then one more time, we need to check this address against the name, and we need to make sure that it's not like a zero address, like it's not empty. So we convert the just follow up and see what I'm trying to do here. Bytes, memory, it's gonna be a memory operation. Say this user, you call me this user byte string, okay, is equal to bytes. Then just capture this guy here and then the name, which is this. Sorry, what to be here, not there. This user dot name. So we're actually assessing the name here, right? This name, we want to make sure that the name is registered. So if this name is not registered, then there is a problem. And that is what we are trying to do. After that, we then do our sanity check, require that this user bytes not length, right? I hope that is the correct spelling of length. It's not equal to 0, okay? And then the give a message in case I could say this wallet does not belong to any or anyone, any account. So after the sanity check, this guy has been warning us since, so let's help him out and probably have some peace of mind in the process. So this is like a modifier, like I said, that checks to know if a user already exists. So if the user is not there, then the person will need to create an account. Okay. Now we've created our accounts. After creating an account on Twitter, next thing you want to do is to interact. You can actually follow somebody. You can post. So for now, let's implement posting. Okay, to post a tweet. Start with function post tweet. Now the tweet, of course, like we said earlier, is gonna have ID. To help us keep track of the tweets as they go, because you could have first tweet, second tweet, third, and it goes on and on like that. And also, you need to keep track of the person sending it, okay, and then the content of the tweet, of course, the timestamp, right? So to do that function, we have to take in the content, which is going to be a string. String memory operation content, right? And then we go for it's going to be external. That is visibility now. Um,
Yeah.
so
Can you hear me?
yeah, somewhat. Yes,
Yeah, I
yes.
have a question. I have a question. So I noticed that in your
All
ID now
right.
there's like a bit of an auto completion on it. Please, what's the extension you used to achieve that?
Um, I'm not using any or any apart from Prettier, which is there. And
Yeah,
then
because
what is it called
I don't get
again?
any.
There is other. Okay, let me check this extension again.
Okay, that would be fine.
Yeah, is it Jualang or I can't remember his name again. Um, okay. Yeah, this guy here. Oh, not flattener, please. Not flattener. Solidity. Let me see. As a guy, Joel something.
Joan
Yeah,
Blanco.
this the guy. Yes, that's the one I'm using. That's the one. Do you have it?
Okay, let me check mine.
All
It's
right.
gonna be
All right. I think that's the only main this thing I have. Every other thing, um, yeah. And then
thank you so
prettier.
much.
Is it there? Okay. While he shakes it, we continue with this. Now, before, well, like we said, before you make a tweet, you need to have an account, right? So we borrow the need, of our guy here. Account exists as our what is it called? A modifier, because you need to have an account before you can make a tweet in the first place. So And who is actually going to make this tweet? Of course, the person calling the function is most likely the person that's going to make the tweet. I think we have the case of someone doing something on your behalf. Sender, right? That's msg.sender, msg.sender, and then we open the function body. So first thing we have to do is to instantiate our struct. So we do that by saying tweet as our tweet struct, right? Memory operation is gonna be, then we have the pointer, memory pointer now. New tweet, new tweet, right? Is equal to the name of the struct. We open up parentheses and begin to pass in our values. This is for the ID of the MSG dot sender, then the content, right? Content, as well as the time. So we use block dot timestamp, which gives you the time of the tweets. All right. So after that, we assign the ID to an ID to a tweet, right? So using our user user struct storage, it's gonna be this user now, right? This user is equal to users as our mapping taking, he's the one calling the function obviously, so he's the one making the tweet msg dot sender. Of course we terminate the process. Then after this, next thing we have to do is to take the tweet the person is making and push it to the array we created somewhere here. His array, that user tweets. So we have our pointer already, which captures everything within the struct. So we have access to the struct. Next thing we got to do is say this user dot user tweet, which is a field in the struct, dot push. Push is sorry, say push, not public. Push is a method on the arrays, right? And we go for the next, that is next tweet ID that we want to push into this place. Yeah. And after this, we increment his ID because yeah, we increment it by one. That is next tweet ID plus plus. So that if it was zero, after you make a first tweet, um the what is it called? You now own the current state, and there will be another number waiting for you to use next time you want to make a tweet. So I think there's something we are missing. Um, we didn't give the tweet ID. I said it, but I did not implement it. Terrible. Okay, so go for tweets. That's the mapping now. Next ID. So if it's one, we want to set it to be equal to this guy here, so that this new tweet will become one. That's the idea, anyways. New tweet. So if this is one here, then the one is set to be pointing at this guy here. Is anything? Why are you complaining? Okay. So I think everything so far works. Are we missing anything? Okay, let's try interacting with this on Remix and see if everything is working according to plan. Um, so I'm going over to my Remix right now. Remix. Okay. Um, Let me open this guy. Okay. Come on. That's the network won't do this wrong thing. Mm, okay. Let's see. Might be better. So we just want to like test our functionalities and see, what's good and know if actually we are getting everything we're meant to get right. Okay. I believe by now most of us are already like unfamiliar with what's it called again? Remix. Remix is not even loading at all. Choco. Is it my network or what? Alright. Okay, if it's not working, maybe we'll just continue with the class. So the next functionality we are going to implement now is after you've posted a tweet, kind of makes sense to like want to read what you've posted, right? So let's try and see if we can implement the read tweet functionality. Hold on a bit. Oh, this is happening. How are we going to interact with the tasker? Okay, it's coming up now. It's coming up. No, I just wanted like to show us kind of a feel of what we're doing so that it doesn't look so abstract and we keep imagining. I hope you can see my screen right now, huh?
Yeah, I was going to ask you, sir. We can only see your Visual Studio.
Oh, oh. Okay, maybe I will have to stop sharing and then reshare again so that I see what I'm doing as depending on this guy. Stop sharing. Mhm. This is not even shipping body. Okay. Let me reshare stores. Okay. Um, oh God. There you go. Okay. Sorry. Confirm. Can you hear me now? And can you see my screen, please?
We can now.
All right. All right. Thank you. Sorry about that. A call entered my phone and you know. Let's open this guy contracts. Okay. I open a folder here. I call you Twee Twee. But so okay. Let me copy everything here. Control A. Let me copy. Paste. Yeah. Let's see if we have error somewhere. Compiler will tell us, and then we progress from there. Why is it taking so much time?
So before the compiler finishes, can I ask you a question?
Okay, sir, go on and ask the question.
Okay, now since the charts are running on the blockchain, right?
Since what?
The Twitter app is going to be
Okay,
running on the blockchain, right?
yeah, yeah.
Doesn't that mean that for every chat or Twitter post, the user will have to maybe pay gas fee or something?
If you're making like a right transaction, like if you want to make a post, you obviously pay a token. Yeah, that's
Mm.
decentralization for you. Actually,
Okay.
in Web 2, you pay for stuff like that too, but then it's with your data that you're paying with it. You don't pay with real money. They say.
And in
Uh,
Web3, we have to come online with data, right?
we have to come online with what?
With our data, right?
Not just. I'm not talking about your mobile data. I'm talking
You
about
mean
your
our information?
information. Yes, information. But in Web 3, don't come
Really?
up with it's your address that you use, which makes you like kind of anonymous. You know, nobody knows you. You are in charge actually. Yeah. So unlike Web 2, they ask you for this, your location, your street, and stuff like that. So I don't think this is gonna load today. Eh? If I try doing something here,
I think I
give me.
spotted the mistake, sir.
Okay, tell me.
Um, it's yeah, pragma solidity 0.8. I think it's supposed to be maybe 0.8 point something else.
Okay, let's see. Point. Say 19. Um, that guy is not still compiling. 0.8 is meant to compile, though. I don't know. Network has been crazy since yesterday. And let me try reloading and know if we have some kind of breakthrough. I just wanted like for us to interact with this. We make our tweets and try getting it back and see, so that we have a better feel of what we're doing. But if this is not working, we just continue going. We don't have all the time in the world. Um, I wonder if we can even deploy this thing. No. So let's go back to something else, I beg. So to read tweets, actually um okay, we need an address, of which that address is what we are going to read its tweets. Okay, let me see if we are having a better luck now. Tweet.so and then now. How about this? Okay, now it's working. So we deploy just the normal JVM, nothing special about this. So we have our list of I hope you can see my screen right now, but um
You zoom in a bit, please.
oh, okay, okay. So I'm bringing it up. Is this better?
Yeah, yeah.
All right. So we're using the first address here, okay, and that's what we deployed the contract with. So to register, we open this field and see it's asking us for string. Let's call it what? BUNN, blockchain UNN, then we interact. Um, let's make this bring this up so we see what's going on down here as well. Um, okay, we interact. We've interacted. This means we've registered, right? Now let's try making a tweet. Say content. This is our first tweet. Okay, let's hope. Maybe that first is going to work. Let's try. Um, okay, now we have this. So it's expected that the tweet ID should increase, right? So let's see. It's currently one. It used to be zero. Of course, we all know that when you define a variable like this, the initial state, especially for uint, is actually zero. I believe we know this already. So um, right here, we can get the tweet by what? Passing in the zero. That's the index of the tweet we made. And we can see something here. See, this is our first tweet. And we have the time, you know, the time it was made. So we copy that time, have time converter somewhere around the corner. Let's confirm something. Or if it's gonna waste our time, we leave it and go. Okay, I think it's wasting time. Let's go back to here. What else do we need to do now? User. Then we'll just carry, we'll get the address. Um, Copy the address. Come down here with paste. I'll click on this. We have one user now, and that is blockchain UNN, and this is well, her address. So I think so far we are right on track. This guy is even still loading. Now we go back to our VS Code and we attempt to read a tweet. So we start with the function read tweets. Okay. Um, but if you want to read a tweet, there has to be address to a particular person you're reading the tweet. User, and then this should be view. So we're not doing anything special. External. External is gonna return what? An array of tweets, obviously, from the person. Returns um, tweets arrays. Okay. So, and it's gonna be a memory operation. Memory. Now, another thing we have to do is we need to try and get access to the storage, right? Because we have this somewhere. Just remind us, this is it. We need to have access to this before we can work with whatever we're working with.
Excuse me, sir.
All right, sir.
Please, I can't remember the purpose or function of this memory keyword. Can you remind me, please?
Memory, it means, let me just tell you the simplest way. It means it works and stops here. You get?
Okay, okay.
It's only available for this function, right? So this function we use it and discard it
What
right here.
What about storage keyword?
Storage is the one that gets written to the blockchain. You pay for something, you pay for it actually if you use storage.
Public ink, or what's the difference between public and storage?
Public is like visibility. You're making your, maybe it could be a variable like this one now. Anybody can see it, or whoever, wherever you are. Do you get that?
Yes.
Yes. Yes. Okay. So back to this. So we get this struct u int as of type array. Gonna be a storage operation with storage pointer user tweet um, tweet ID. That's his IDs. But once we have access to the IDs, we have access to the tweets. So we set it to the address of the person we want to read their tweets. That is users. sorry, should be users. That's the mapping we are tracking. And then we pass in the address user, that's this guy here. Then dots user tweets, right? Tweets. Okay. Enter mismatch. Where is the error coming from? Expected what? We're doing something wrong. User tweets.
Yeah, can you hear me?
Yes.
The there is no opening curly brace for that function. So you have to place one after the memory, the return
Okay,
memory
okay, okay,
sign.
okay, 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 okay. Yeah,
Okay.
terrible. Too much groceries.
Easy, easy.
I'm ready.
Oh god. So yeah, here we go.
No,
Here we
remove one
go.
now. Remove one now.
I think we are right on track.
Under
Is that not
it.
it?
It's an extra
No,
one.
this is for the contract
Okay,
actually. Let
okay,
me take
yeah,
it
yeah, yeah.
down.
That's true.
Okay, that's true.
Yeah, this is for the main contract. So thank you for that, man. So after that, then we create a dynamic array. Okay, dynamic array of tweets. Gonna be of type tweet. Um, this is gonna be a memory operation because we don't want it going any further than what it is at the moment. User,
So please, I'm confused.
okay. Where is the confusion coming
Um,
from?
you said the storage keyword is used to like specify maybe
Access
data that.
something from the storage.
Okay, I
Do you
just want
get
to understand
that?
like, yeah,
Okay, okay.
is we are reading this function is supposed to read tweets, right?
Yes.
So why do we have storage keyword behind this variable here?
Which variable are you talking about? This one?
Yes, user tweet
Because
IDs.
of the nature of this guy, where it's coming from. It's coming from the state variable. The uint here
Uh-huh.
is coming from this guy. These are state variables. Do you remember?
Yes, yes.
And state variables have access to the storage of the blockchain.
Oh, okay.
Yes.
Makes
Yes.
sense.
So that's what we're doing right now.
All right. Makes sense.
So we're
Thank you.
assessing this guy here. Yeah, we're assessing this user tweet, which is an array of uints.
Okay.
Yeah.
All right. You can continue.
Okay. So after that, we move on to user tweets. We're trying to capture all their tweets. Then we instantiate a new, um, you know, tweet array. And of course, when you define an array, you also get the what is it called? The length, dynamic arrays. We need to attach the length, and we get the length by using this ID. So the number of IDs the person has should be equal to the number of tweets they've sent out, right? So we go for user IDs dot length. Um, yeah, that should give us what we need, and then go from there. Um, next thing we have to do is loop over the IDs, right? And then while we are looping, we'll be setting the IDs accordingly. So go with four. The way you do, I think this is more similar to what we do. Um, uint, sorry, uint. Int I, we're initializing it, so it starts from zero. Um, okay. Then I, as the guy we are iterating with. Less than or equal, okay, should be less, not equal. User IDs, right? Dot, of course, the entire ID length. Um, and we increment the iterator. Incrementing it should be I plus plus. And now the body of the um, loop. So we want to set user tweets at a particular point. User tweets, say at location I. Sorry. So it could be location one, location two, and so on and so forth. Is equal to the tweets, as tweets mapping now is what we're assessing, and user ID, right? Okay. Is that someone entering or equation? I've not even checked the charts for a while.
Yeah. Hello, can you hear me?
Yeah.
Yeah, that's line 60. The
Okay.
line of
60.
code yeah, yeah, it's looking crazy.
Okay.
It's
This
looking like
is.
it's stupid.
Is it is what?
Like it's looking like I don't understand it. We have I think we create like an array of like tweets.
I,
Okay, so we
your
should
voice
have
is kind of breaking.
can you
So
hear me
I
now?
think
Hello?
Okay. Okay. Yeah.
Yeah, if you could please explain line 60.
Okay. Let's start from here. This is a struct, right? Remember this is a struct, right? And then we are making it a struct of arrays. Memory operation, we have the pointer which points to the memory. The new, is it the new keyword that is confusing us or what? Please, the person that asked the question, like, is it the new
Yes, yes,
keyword?
yes, yes, yes.
Okay, like this is a way to define a dynamic arrays in Solidity. Do you get that?
Okay, okay.
Yeah, this is syntax actually. So there's nothing different that we have not been doing before now. Yeah,
So, but you
and
have that user's tweet ID dot length in the brackets.
yes,
Like does that
once
like
when
define like the size of the array?
yes, eventually, but we don't know the size at the moment, and the size could be three, it could be four, it could be five. Do you understand this?
Okay,
Yes, so it's dependent on the number of IDs from here. It could be 10, it could be two. So we're just trying to target it, whatever it is, that should be the length or size of this array.
okay.
Yeah,
okay, sir. I have my own question, please.
all right.
Can you still, let's say, assign this Twitter array to this user tweets without using the new keyword?
Like I said, this is like the syntax for dynamic arrays. I don't know if there's another way, but for dynamic arrays, arrays that changes, right? You
Yeah.
have to use the new
Arrays that
keyword.
changes how, please?
It's dynamic.
Okay.
Right now here, this IDs is the ID of your tweet, right?
Yeah.
So you could have one tweet in your account,
Okay.
another person could have 20. Do you get that?
Yes.
So another person could have 15. It's changing. It depends on the user coming in.
Okay.
Yeah. So maybe later after the class, you might want to read up arrays and how you instantiate them to have a better understanding.
Okay. Yeah, I think
Okay.
so because I'm looking at it with the JavaScript perspective. But
No,
continue.
no. This is Solidity actually.
Okay, continue.
Yeah. All right. So after this operation, we want to return um the entire user's tweet. Return um user the tweets. Okay. I I think that's about that. What else do we need here? So the next thing we have to do right now, yeah, let's test it out and see what's up. Yeah, it's always good to do these interactions. Hopefully, our guy won't waste our time. If he wants to waste the time, we'll kick it aside and move on. So I will just paste this here. Uh-huh. Okay, it compiled. So let's delete this guy and then we redeploy again using the first deploy. Okay, let's interact. So first of all, we register. Let's go with blockchain UNN2, right? We click on register and it was successful. Okay, now let's okay, this is our second and third tweet. Okay, post our tweet. Now if we come down somewhere here, we can see the um retweet kind of function, right? So and it's requesting for what address. Okay, let's get the address, which is the first address here. We come down, we paste it, and then we query. Let's see what. Okay, this is it. This is our second and third tweet. Like, and then we have the timestamp. You know, the time was. Let's see if this works now. Okay, if I paste this here, please don't waste my time. I convert. And this is like that's terrible. It's trying to take us backwards. Oh, bro. Let's go. But the idea is this: you can actually check this out later, and you realize it is close to the time we have here. You know, this 8 for something should be close to that, and then we have the address. Yes, someone trying to talk. Okay, so we have the address that we made the tweet, and of course, the number that's the index, which is 0 at the moment, and this should be 1 like always because it's waiting for the next tweet. And if you make another tweet, it will increase to 2. So we go back to our VS Code. Now we have these basic functionalities going for us. Next thing we might want to implement is maybe follow and following. So you want to follow somebody now on on Twitter, right? So in order to follow, the people you're following are actually like properties of the user, right? If I'm following somebody, the person's profile, it's not profile per se, but I will see that I'm following somebody. I believe most of us here are conversant with on Twitter, right? So you will see the people you're following and the people following you, and this is like in your own space. So since that is the case, what we have to do is go back to um, our user struct, which is up above. Yeah. So we can add another set of variables here, like address of, I'll make it an array so that everything will be together, right? Address of people you're following. So the name of the following, and then another one is we want to track them by addresses. Yeah, address of um followers, people following you. So you have people you're following, and then you have people following you. So I think that should be done for now. So we go down again to where we was. Oh boy. So we start with another function that implements fellowship, right? Not fellowship in terms of church, just like we want to follow each other. If I follow you, you my details will be stored in your part, and yours will be stored on my part. So let's try and implement that. Call that function follow um follow user. Okay, so we go for this and want to get the address of the person we want to follow. Obviously, address of the user we are aiming to follow. Um, Visibility should make it external. How big is? Of course, before you can follow somebody, like we said earlier, you need to have an account with Twitter. So we check if the account exists. So we use our modifier, which we kind of you know declared earlier. And the person you're following as well should be on Twitter. It makes sense, right? Because if the account doesn't exist on Twitter, there's no way you can follow them. Yeah. So accounts exist. Um, MSG, sender. Maybe I mix this up a bit, but you get the idea. This is the person you want to follow, and this is you, the guy calling this function. All right. So I think we are ready to move into the body of the function. First thing we have to do is access our user storage again. So we go with user um, storage, right? Talking about a user now. User, that is function caller. The person calling this function, we want to prioritize him because it's that person that will determine what happens there, right? It's the one that will click the follow button. So we call him the function caller. Let's use the function caller is equal to mapping we have already, and it's going to be set as MSG sender because yeah, it's the one that owns it. And then so once we set this, we can now access our struct as the followers, which we just hey, that reminds me, I need to shake my charts. Okay, all right. Let's see. Okay, this I think we've answered this before. What about changing exactly? What's don't if you can mute or mute and speak up, please. That might help us because I don't understand.
Yeah. Like I forgot to ask about this one. Yeah, you said that the array is changing. It's a dynamic array, right?
Yeah,
So I'm like, I know arrays used to hold any maybe anything inside with their index, but I
yeah.
don't understand what is changing about this particular array. Like it's giving me syntax error in my head.
I just told you now. What is changing basically is the length of the array. I
But
told you before,
okay,
right?
without declaring it as a dynamic array,
Yeah.
doesn't the length change normally?
No, in Solidity we have two types of arrays: the one that's fixed
Okay.
and then the dynamic.
Really?
Can we check it out?
Yeah, let's check it out, please. Sorry.
Okay, let's see how many types of arrays do we have in Solidity. Hopefully, network will help us. Say we have two, right?
Yeah, I can see that.
Yes. So maybe after the class, you can go on and explore, like we said before. Okay.
Okay.
It seems you have not been following the classes or like
No, I've been following the classes, but this particular array stuff.
yeah, array is usually tricky actually. You're not alone in this. So yeah,
All right, continue, sir.
yeah. Okay, bro. Thank you. Um, so we go back to these guys. All right. So after we um this this is our what is it called? Our user struct. Like once again, we are trying to access something from it, and this time around, it's gonna be um the user. It was captured in this. That's the pointer, right? So we go with function caller dot following um then dot push. We're pushing it to the that should be the user the person wants to follow, right? I hope we understand this. Yes, we do. And then after that, we also need to update this process for the person he just followed, right? User storage, um, call it user now, because that's the person we are trying to follow, is equal to um, the okay, underscore user. Um, so we use the pointer as well, dot followers. So I hope you understand what's going on here. Dot push um, msg dot sender. Okay, yeah. So what's happening here is this. First of all, we get we get the access our storage variable here and get the oh gosh. Okay, first of all, we get we set the address to somebody, right? And this storage pointer here is now pointing to following, which is the struct we arrays. This is it. Following, this is it. This is where we are. So the function caller is at this point and it's pointing towards this. And now we are pushing values into this guy. And then for the person we are following, we need to update the addresses as well. So the person we are following, his address comes into our okay, our array, while our own address goes into their own array. I don't know, it's a bit confusing, but it makes sense, right? If I'm following you, I will get you on my list, and you also will have me on your list. It's that simple. So next, we now get the followers and then the following. So we use function get. Yeah, I was told to take screenshot or something. I'm not doing that. How am I supposed to do that, man? Oh, Darlington, are you there? Okay.
Yeah, yeah, I'm here. I'm here.
About the screenshot and something like I don't
Okay,
know.
I've
Okay,
already taken the screenshot and the attendance. Don't bother about that. Just continue.
okay. All right. So about getting the following, get following, right? Go with external special. It's gonna be a view. It's not changing anything. Then of course the account must exist before it will talk about someone is following him or not. Yeah. So in this case, we're trying to get the MSG the sender, right? And then it's gonna return array of something, an array of addresses returns Why is it giving me warnings? Why don't it again? External view account exists. MSG the sender. Okay, let me just keep going. Returns um address. Address. Where is my autocomplete? Way of address, and then we have memory. It's memory operation. Memory, right? And then all we have to do right here, okay. Let's see what we're doing there. Is a return user MSG sender um dot flowing follow flowing. So I return the followers here. List of people our user is following. So okay. Now let's get the people that are following him. They all go the other way around. Say function get followers, right? External view, because the account has to exist. We need to check for this as well. Then MSG dot sender should return something. Returns array of addresses as well. Address okay. This memory operation. So we have to say return user MSG the sender and followers now. Followers. Okay, I think that's about that. Hopefully there's no error somewhere. So after that, the last functionality I think we'll be implementing is message. Okay. So the ability to send message to Mr. A, and also Mr. A can receive your message, right? So in order to do that, we have to remember the message is a string, right? So have to it will have some kind of properties. String, just remember when you send message, the properties you normally have. We need a way to keep track of the messages. When you send the first message, second message, so we need an ID obviously. And it has to be a string, okay. Then talk about the person you're sending to. That person in this case is a wallet, right? It's an address, and you also have an address. So at least it has four properties. It could have more depending on the kind of stuff you're trying to build. So, but for what we are trying to achieve here, we just stick with these four functionalities. So we could go up and create a struct, you know, another struct. This will be for messages alone, struct message, and then we populate the field uint, not unit, uint message ID. Okay. And then we have something like string, and that should be the content of the message we're sending, like hello, hi. And address form, address, address two, right? Okay. So one more thing we need to do for the user It has to, a way to keep track of the messages you are sending, right? If you send the first one, it goes. Second one as well goes. You need to keep a track of that, and it's going from a wallet to um to the user. So it kind of makes sense to like have a mapping under the user, right, with which he can track his conversations. So we map mapping of address would be the messages we have these properties, and then we want to store it in an array. Okay, and then we call it conversations. Call over. Let's see. Showings. Okay, and then let's go down and implement the functionalities. Think we are almost out of time though. Um, so the next thing we have to do is function send message, right? Functionality send message. Um, we need the address of the recipient, person that is going to receive the message. We call him recipient. I hope that is correct. And then the string, the content of the message. We use memory here. Um, memory, actually contents. And then, of course, let's set the visibility to external, no problem. Because the person we are sending to needs to be on Twitter. So obviously, um, and we sending message must have accounts on Twitter as well. So we check for that. Have account exists. That is for msg dot sender, right? And then account exists as well. Account person we are sending to. Here is my account. That is correct. Um, okay. Recipients. Let's see. Recipient. Okay. Then after that, we open our function body and then we begin implementations. So first of all, we grab our memory. That's message actually, not memory, please. Message. Then call it a new message. New. Let me make this sexy. New message is equal to instantiate the message struct from above. That is first of all we need the ID. Yes, we need a way just like what we did earlier when we're keeping track of the tweets we made. We need a way to keep track of the IDs. So within our state variables, we defined kind of a global, yeah, under this guy. Uint, not unit, uint, public. Call it um what? Next message ID. So if currently we have one, once we send the first message, we expect this particular ID to increase to the next available joint. So we call it next tweet. Now is message message. Yeah, I'm in the process. Are you still complaining? What do you say? Mute. Mute. New message. Can you save? Expected identifiable gone new. What do you mean you got new, bro? If I take out this, does that help us? Okay, someone is going bananas here. Okay, let's just continue. I don't know. My guy is all of a sudden acting up. Say expected identifiable gone new. Like, let me just clean it off. Okay. Now new um okay. I think that's like next message. Let's use this. Next message ID. How about this? It's no new, bro. Okay, I don't know what's going on right there, but someone is messing with us. So let's continue for now and see maybe later they will kill themselves. Um, so message, we have to keep track of the next message ID, yeah, and the content which we passed here as the parameter. Of course, the person calling the function, obviously, that's the sender. We call him MSG dot sender and then the recipients, right? Recipient. That's correct. Okay. So after we um instantiate our struct, let's go back and see again. Has it disappeared? Identifier. Okay, this is not correct. Accounts. Yeah, and could be a problem here. I think that should be fine. All right, this is better than red. So we need to access our storage one more time. We have to set the values. So we go with user as the user struct storage. I'll get our pointer sender, right? And sending the message is equal to we track him with our mapping and then get his address is the MSG sender. So the other guy later cleared out himself. Awesome. So now we track that conversation. Say send. This is like our stroke now. Everything this guy has, this other guy possesses it. Okay. So we have sender dot conversation, which is the name of the mapping within you know, let me show us name of this particular, yeah, this guy. So we are at this point and we are targeting this guy. Eventually we will end up here and I have to point this to this our array right here. So go for conversations, um the address, which is the address of the recipient. Recipient. Now we are push those messages to him. Okay. Push our message. The messages is new this guy here, when we instantiated here. Okay. Someone is doing something on the chat. Give me a second. Or you can unmute and speak, please. Okay, let me see. Okay, we're almost there, sir. We're almost there. Don't worry. When you go through the videos, I think you have a better understanding of what's going on. Um, we go do after class. Okay, let's see. Let's finish up. We're almost there actually. Um, so we are pushing the message now into this. Um, this is an array actually. The way it is here is an array contained in our struct user struct. So we are pushing the. After that, um, we update user. We update our own side as well. User storage recipient inbox without. I don't want to. Yeah, this is better. User um targeting recipient now. Okay, and then go for. We're just trying to read recipients. Okay, I was supposed to assign this. That's not it. Yeah, this is it. So we go for the recipient dot. Well, moving into the conversations again. Then we're targeting MSG sender, and we'll push everything. Push, right? Push the new message to him as well. New message. Okay. So after this, we just increment our say identifier not found. Maybe there's a mistake somewhere in this thing. Okay, I'm talking about massage instead of message. I think that should fix it. Right. So after that, we increment our message ID to the next message ID plus plus. Right. So after that, we just get our conversations and we're done. Right. That we go for. So we need to deploy and then run some interactions. Our function gets conversation, right? Conversation with user. Okay. Add address. We're trying to get address of the person we want to get conversation with, and then user. External. Just visibility now. Nothing special. And it's a view. It's not making any change, right? Then I returns actually. Not just return. Then I return array of messages. Array of messages. And it's gonna be a memory operation. So we open our function body. We access our storage one more time. Storage, get our storage pointer. This user is equal to try to get the conversations of the sender, right? MSG sender, and then we return this user dot conversations, the message he had with a certain user underscore user. Okay. I think that's about that. Let me Is my terminal still somewhere? Can't find it. Let me just open another one. Okay, let's try compiling the contract and see if there is a mistake somewhere or um, something else we need to implement. So I think it's yarn compile error. Compile not found. Are you sure I'm running the right command? Okay, let me just forget about doing this. To deploy, we use I think it's npx. Um, at the point of the yeah, alright. So npx run I think it's script. I'm not sure. Which setting? Okay, had that. Yeah. And we are deploying to Sequoia, right? Um I believe we are used to working with Hardhat before now. So I want to go through the config
Yes, you
and
can do that, sir.
you see?
I can do that. I don't know. You
Okay,
can
okay,
do
okay,
it.
okay, okay. Okay, okay. So all I have to do now is deploy my this is the script. I think I already prepared it ahead of time as well. Okay. I think our own is just Twitter, not Twitter one. Let's confirm it. Okay. This guy here, just for the fun of it. This guy. So we can actually change a couple of things here. Make this to be tweet, tweet. Um, this is like your script for trying to get something here. Tweet. Yeah. Let me just paste this somewhere here and just confirm everything is alright. Try highlighting it. Okay, everything seems fine. So let's run and hopefully um we won't have issues. If we do, wow, okay, our contract just compiled. Let's hold on and see what's next it has in store for us. Okay, it's gonna taking time. Hopefully, yeah. Let me say connect some connection timeout or what. It's like a new one. Let's try it again. Don't give up. Um, if it fails, we try again. We have at least 10 minutes, so it failed again. I don't know if it's my network that's doing this thing or something else. Let's hold on. Same error. Wow. Too cool. Give us something different because in oh voila. But basically all we have to do from here on now is deploy this. I'm just trying to see if we can interact with it on our interscan. That's all we have remaining. Let me log into my MetaMask. Okay, this guy is opening. Alright, so let me go back to his code and see what is happening. Same story. Alright, let me know how to appease the gods. So they can give me this thing one more time, just once, and everything will be alright. If I run from here, will it make any difference? I doubt. My network is not even connected. Are you sure? Wow. Hello, can someone hear me?
Yeah, we dey
Um,
hear you, sir.
Yeah, I can
okay,
totally hear you. I can hear you.
okay. I think my network is the issue here. Let me turn it off. Connecting. Okay. Let me see. Wow. I think this will work. Let me just try.
Okay, I think we lost CC and we are already running out of time. So I'm just going to send him a DM once to see if we can still get him on the call. But we still have another class next week, so he might just continue next week. But let me see if he. Okay, CC is back. Hey, yes, CC, can you hear me now? Hello, CC, can you hear me now?
I muted myself. Yes, yes, I can hear you.
Oh, all
Can you
right.
see my
So
screen now?
no, not yet, not yet. We can't see your
All right.
screen.
Let me just share it so that we see if this will work. Else, that could be our take home eventually. Let's try this one more time. Um, can you see it now?
Yes, sir.
All right.
Yes, yes, you're seeing it.
Okay. Network is messing with us. Can you go now, please? Oh boy, it's not gonna work. So I think this is a network issue. Okay. Since yesterday, network has not been stable. I I don't just know why. Same issues. Time shake out. Time out. Well, let's see if I wanted us to interact with this using you know on a task scan actually. But okay, let's see if we can deploy this using a remix. See if that will work. That's not really the primary. That wasn't the primary objective of this class. But it just hopefully this guy will work. Okay. Where is the remix again? Okay. So I will paste everything I have, and then yeah, that's okay. So I will switch to my injected provider. Let's see if we have some luck here. Um, can we try one more time? Wow, so totally gonna fail. Let's go back to this one. So delete. Okay, it's been deleted already. So let's deploy. This one is safe. So guys, I don't know. I think we will have to work on this ourselves later. But there's nothing else to do other than to like okay. There's nothing else to do other than to like deploy. Even my injected provider is not okay. I think it's here now. Okay. Yeah, yeah. Let's try deploying premix and see what happens. Okay. Um. All right. Then you accept. I believe we are already used to this kind of stuff. Let's view the transaction on Etherscan so we can follow it up. One do Christmas for me now. Let's see what they play with my mind. Um, Still the same old story. Okay. Yeah. So okay, this one is even okay. Now um it's been deployed. Let me open this guy. It's not open here. Everybody is just so sluggish. Um, wow.
So I have a suggestion.
Okay, tell me.
What if you share the link maybe on GitHub so that one of us can deploy it on the Tascam?
Okay, like you mean the contracts?
Yes, yes.
Okay, let me see if I can create. That one fit be problem sef, cause this network as I dey share, the thing just choke. GitHub gist. You know how this guy plays. Um, okay, why not just click on it? If I which recording? So let me see how I can get in. Nothing is loading actually. That's what's part. Don't worry, I will share the. I will host it and then share it. Share the link to the class later. Okay.
All
Right,
right,
sir,
all
no
right.
problem. No problem.
Yes. Yes. So I think we'll be stopping for today here. Yes. Let's all don't try. Which we don't try, Sha. So Darlington, are you here?
Here, I'm here, I'm here, I'm here.
All right. All right. Please take control.
All right, thank you so much. See, I believe we still have another contact next week, so we could just continue from there. And I
Okay.
guess we actually supposed to have still reverting back to two contacts a week. Is anybody here still writing exams or anything? No, I'm just going to end the recording now.